Okay, we're recording again. Back to the PowerPoint. So the neural layer of the eye has where the photoreceptors are. All of these cells are connected to the optic nerve. We're going to talk about ganglion cells and bipolar cells and rods and cones. We're not going to talk about the amacrine horizontal cells. So if you look at the retina, and there's WebAssign that has pictures very, very much like this, that you'll have to identify the various layers. So light comes in, goes through the ganglion cells, passes through the bipolar cells, and then into rods and cones. So for some reason, the light passes through these first layers before the rods and cones are stimulated. And how does light get in through all that tissue? So I mentioned earlier the optic disc is where the optic nerve enters the eyeball and connects to all the nerves. There's quite a few rods and cones, and this is the blind spot at the optic disc. So here's the sclera, and then the choroid, and then the neural layer. If you look at what the ophthalmologist sees, or the optician, they can look at the state of your blood vessels, they can see the blind spot, they can see the macula lutea, which contains the fovea, which is the location of the most cones for color vision. There's two chambers, the anterior cavity and the ciliary body and so on, that's going to connect to the lens. You'll have an anterior compartment between the cornea and the iris, and posterior chamber between the iris and lens, and then posterior cavity, which is the entire large space filled with vitreous humor behind the lens. So the aqueous humor is secreted, flows into the anterior chamber, helps eye shape, gets rid of waste, provides nutrients, it's reabsorbed. Excess humor leads to glaucoma. I won't ask you about the canal of Schlemm. So if we look at another pictorial representation, here's the anterior chamber, here's the posterior chamber, here's the suspensory ligaments connected to the ciliary processes right here, and then the ciliary body, and then the ciliary muscles behind it. So here's the posterior chamber where the vitreous humor is. So here's the pupil, and here's the iris. Okay, the lens is attached to the suspensory ligament. It's built from transparent cells. Back in May, I had cataracts, which means my cells weren't very transparent. So luckily I was able to get two artificial lenses, and I got the standard version so that I can see the screen perfectly. I can now drive, because before I had cataract surgeries, my eyes were basically useless. Luckily I could still see a little bit, but now I can see very, very clearly. So all of you students, male and female, will get cataracts. And this surgery is spectacular. Took about 30 minutes for each eye. As soon as they put the artificial lens in, I can see far. Then I have to wear glasses for near vision. But depending on how far I can get from my computer screen or from a book, sometimes I can take my arm and hold my phone at the end of my extended arm, and I can see fine. So light passes through the cornea, goes through the anterior cavity, the posterior chamber, and then stimulates the photoreceptors. So I said cones are most numerous in the fovea, and in bright light provides detailed color vision. Rods are dominant on the periphery of the retina, provide coarse color-free vision in dim light. But we have to have bright light for the cones to detect color. And just think of all the colors we can see, and artists can use a glorious collection of colors. And nowadays, you can go to a museum or you can just look at your computer. Okay, let's stop there. Go back here, stop recording.